In the previous video, we ended with the statement that a reflection is an isometry. Remember, an isometry preserves distance. So we're going to just prove that a reflection preserves distance. And if you look in the proof, the last proof we did in the previous video, we showed that for an isometry preserves angle measure. Well, a reflection also does, and the proof is identical to that. And we also proved that isometry preserves betweenness. And the proof is identical for this, for the reflection. And collinearity. The only one we did not prove for reflection is distance. So I told you that a reflection is an isometry, but we haven't proven it yet. So the proof that all four of these hold are preserved for reflection. By the previous lemma, we already proved that one, and that one, the A, B, and the C. Now we're going to prove the D. That's why this theorem is called ABCD. By the previous lemma, we proved the first three. We only need to show that a reflection preserves distance. So let's let X and Y be 2 points on the same side of a line L. I've got the line L drawn here, and I drew X and Y. You don't have to draw them there if you don't want to, but draw them on the same side of the line. And then we're going to sketch their images, their reflections on the other side of the line. That's going to be how we start. So remember how you draw a reflection around a line. You drop a perpendicular to the line, and then you double the size of it. So this is where I would have my y prime, and then drop a perpendicular from X to the line, and then double that length of that to get to the other side, and we will call that X prime. Okay, so we have, let's see, sketch their images. We did. All right. Now, before we continue, there are other cases that I'm not going to prove. This might be homework or test questions. Suppose X and Y were on opposite sides of the line. The proof would be very similar. Or maybe they're reflected about a point, not a line L. PFTS says that's going to be a problem for the student. Maybe an exam question. Okay, but it'll be very similar to this. Okay, so draw the line L. We've already got it. Draw the line segment XY. And draw the line segment X prime, Y prime. Okay. We will show that the length of XY is equal to the length of X prime, Y prime. Label the midpoints of line segments XY and X prime, Y prime as M and N, respectively. Well, that's easy. The midpoints lie on the line that this is reflected about. So this point is M, this point is N. Notice now we have two quadrilaterals here. Okay, we labeled them. Mark the right angles. Well, we know that's a right angle, because we dropped perpendiculars. So those are the only angles that we know are right angles. I've indicated them with these little squares, light squares. Okay, and now let's look at corresponding parts. Because N is the midpoint of line segment YY prime, we know that length and that length are equal. Likewise over here, this length, XM, is the same as X prime M. All right, so let's see, what do we have? Now we have enough information to say that our two quadrilaterals are congruent. MXYN, this top quadrilateral, is congruent to MX prime Y prime N. Do you remember why that is? Notice we have side, angle. Oh, this is a common side, so I'll mark it once. We've got side, angle, side, angle, side that are congruent in both of these quadrilaterals. So that's the justification. Side, angle, side, angle, side. Okay, well, if they're congruent, then we know that xy, which I'll put 4 marks, 1, 2, 3, 4, is equal to the length of x prime, y prime, 1, 2, 3, 4, because corresponding parts of congruent figures are congruent. Corresponding parts of congruent figures are congruent. Pretty simple. So therefore, reflections preserve A, B, C, and D, angle measure, betweenness, collinearity, and distance. Okay, last example for this video. It says find the equation in the xy plane. So I've got an xy plane here of the line of reflection L if the reflection around L maps -4, 5 to the point 6, 7. Okay, we have to find which line. There's only one that does it. So we have to find the equation of the line L. Well, let's plot these 2 points. -4, I've put some notches on here. -4, 5. 1, 2, 3, 4, 5. Be about right there. I'll even mark it -4, 5. And then 6, 7. 4, 5, 6. And then we'll go up 1, 2, 3, 4, 5, 6, 7. Will put us about right there. All right, well, what do we know about the line L that maps this point to this point? One thing we know for sure is that the line L goes through the midpoint of the line segment that connects those. Okay? Because it's a mirror image about that line. Okay, the line L contains the midpoint M. What is the midpoint of those two? Well, you find the midpoint by averaging the x's together and then averaging the y's together. M is going to be -4 plus 6 over 2. And that's the x value. The y value will be 5 plus 7 over 2. All right, let's simplify that. And what is the midpoint? Looks like the midpoint is 6 minus 4 is 2. 2 over 2 is a 1. And then 5 plus 7 is 12. 12 over 2 is 6. Okay, so let's go to 1, 6, and let's plot M, the midpoint. 1, 2, 3, 4, 5, 6. Okay, so that is my midpoint. I'll go ahead and draw the, we don't need to, but draw that segment. So I know a point, but now I need to get the slope of the line L. Because if I have a point, 1, 6 is on the line. If I know a point and the slope, I can compute the equation of the line. So just for fun of it, we could draw it. We know it's got to be perpendicular here. Now, I don't know. I don't trust that. I don't trust my markings here. I don't know if it goes exactly through 2 here or not. But this is the line L that we're trying to find the equation of. So what is the slope? The slope that contains these 2 points, -4, 5, and 6, 7, that will help us. Okay? The slope connecting those 2 points is going to be, I'll write it like little m for the slope, equals All right, so it's rise over run, the difference in the y's over the difference in the x's. So I'll go 7 minus 5 on top. And then go 6 minus negative 4 on the bottom. Let's see what we get here. 7 minus 5 is 2. 6 minus negative 4 is 6 plus 4, which is 10. So m is 1/5. So what is the slope of the line L? If the line perpendicular has a slope of 1/5, what's the slope of the perpendicular line to that? Remember that? Well, slope of line L is the negative reciprocal of 1/5. So once again, if a line has a slope of 1/5, the line perpendicular to it has a slope of the negative reciprocal of 1/5, which is, reciprocal is 5 and then negative. Okay, so now I have a point here, an ordered pair, and I've got the slope, which is negative 5. So the equation of the line L is, I'm going to use the point slope form, y minus y1 equals m times x minus x1. This will be my x1, y1. So I'll get y minus 6 equals negative 5, the slope, x minus x1, which is 1. We're almost done. I want to write this in slope-intercept form. So that would be, let's see, y minus 6 equals negative 5x plus 5, because negative 5 times negative 1 is positive 5. Add 6 to both sides, and we will be done. Add 6. 5 plus 6 is 11. Okay, this is the equation of the line L.